Look closely at this image. Notice the faint, ghostly imprint of a man, a bearded figure, his body marked with wounds that seem to tell a story of immense suffering. For millions, this isn't just an ancient textile. It is the very cloth that once wrapped the body of Jesus Christ in the tomb. For others, it is an elaborate and ingenious hoax, a medieval creation designed to deceive. This is the Shroud of Turin, and it is arguably the most controversial, scrutinized, and enigmatic object in human history. It exists in that shadowy space between faith and science, a single piece of linen that has provoked debate, inspired devotion, and defied every attempt at a definitive explanation for centuries. We are not just looking at a relic, we are staring directly into one of the world's most profound and enduring mysteries. The question it poses is as simple as it is monumental. Is this tangible, physical evidence of the most pivotal event in Christianity, or is it the most brilliant and enduring forgery ever created? That question has launched a journey of investigation that spans the globe and crosses the boundaries of academic disciplines. For decades, teams of scientists, chemists, physicists, pathologists, and forensic experts have subjected the shroud to the most advanced analytical techniques available. They have peered at its fibers through powerful microscopes, analyzed its chemistry, and even subjected small samples to radiocarbon dating. Yet, for every finding that seems to point toward an answer, another piece of evidence emerges that complicates the picture entirely. The mystery only deepens. How was this image created? The science tells us it is not a painting. There are no pigments, no brushstrokes. The coloration resides only on the very topmost microns of the linen threads, a feat of technology that, some argue, no known medieval artist could have possibly accomplished. The wounds visible on the body align with shocking precision to the descriptions of the crucifixion from the Gospels, displaying a knowledge of Roman flagrum whips and ancient crucifixion practices that was largely lost to history for centuries. So, where does that leave us? It leaves us on a fascinating and at times unsettling exploration that touches upon the very nature of belief, evidence, and history itself. In this video, we are going to walk that path together. We will retrace the steps of historians tracking the shroud's elusive journey through time before it appeared in the historical record in 14th century France. We will examine the shocking results of the radiocarbon dating tests that seem to settle the debate once and for all, and then we will dive into the compelling scientific and historical arguments that have challenged those very conclusions. This is not a story with a simple ending, but it is a breathtaking journey through forensic history, human ingenuity, and the enduring power of a single, silent object to captivate the entire world. Prepare to look at this piece of cloth not just with your eyes, but with your mind wide open as we attempt to unravel the secret of the Shroud of Turin. Let's begin by getting a clear picture of the object at the heart of this mystery. The Shroud of Turin is a single, large piece of hand-spun linen cloth, measuring approximately 14 feet 3 inches long by 3 feet 7 inches wide. That's a little over 4 meters by 1 meter. The fabric itself is woven in a sophisticated herringbone twill pattern, a style consistent with textiles from the ancient Middle East, not just medieval Europe. Upon this cloth is the faint, straw-colored or sepia-toned imprint of a tall, well-built, bearded man, appearing to be in his 30s. The image is a full-length, front and back negative, as if the body was laid flat on its back on one half of the shroud, with the other half drawn up over the head and down the front. The figure's hands are folded across the pelvis, and the image captures an astonishing level of detail, from the strands of the man's hair to the contours of his musculature. Superimposed over this ghostly portrait are very distinct, darker stains that forensic analysis has identified as human blood. These are not part of the image itself, but appear to have been transferred from wounds on the body before the mysterious image was formed. We see flows of blood from the scalp, consistent with a cap of sharp thorns, scourge marks across the back and legs as from a Roman flagrum whip, a large wound in the side, and most tellingly, traumatic injuries to the wrists and feet, suggesting piercing by heavy nails. Today, this revered and controversial cloth resides in the royal chapel of the Cathedral of St. John the Baptist in Turin, Italy, where it is kept within a custom, climate-controlled case, rarely removed for public viewing. Its status, however, extends far beyond that of a typical religious artifact. It is, without exaggeration, one of the most intensely studied objects in the entire world. It has been examined by teams of physicists, chemists, pathologists, textile experts, and forensic specialists, all attempting to apply the tools of modern science to unravel its ancient secret. For millions of the faithful, it is precisely what tradition claims: the actual burial cloth that wrapped the historical Jesus of Nazareth after his crucifixion, a tangible, physical connection to the foundational event of their faith. This belief transforms the cloth from a simple archaeological curiosity into a sacred relic of immeasurable spiritual significance, making the scientific debate about its age and origin not merely an academic exercise, but a profound inquiry touching the very core of history and belief. But the trail of the shroud doesn't begin with laboratories and electron microscopes. It begins in the foggy annals of the 14th century. Our first solid, undeniable historical footprint for this object appears in the small town of Liéry, France, around the 1350s. At this time, a French knight named Geoffroy de Charny is credited with placing the cloth on display for veneration in a local church. De Charny was a celebrated and pious nobleman, a veteran of the 100 Years' War, and his motivations for presenting the shroud remain a subject of speculation. Was he a devout man sharing a miraculous discovery, or was he the savvy patron of a clever enterprise? The context is crucial. Medieval Europe was a world saturated with relics. The bones of saints, fragments of the true cross, and countless other holy objects were sought after by churches and kingdoms alike. These relics were not just articles of faith. They were spiritual tourism, drawing pilgrims from across the continent and bringing immense prestige, influence, and financial donations to the towns and institutions that housed them. In this environment, the sudden appearance of the ultimate relic, the very burial cloth of Christ, would have been a seismic event, and it was an event that almost immediately attracted powerful opposition. The local bishop of the diocese, Pierre d'Arcis, launched a formal investigation. In a memorandum to the anti-Pope Clement VII, Bishop d'Arcis made a stunning accusation. He stated that his predecessor had looked into the matter and had discovered the truth, that the shroud was a clever fabrication. Most explosively, d'Arcis claimed that the actual artist had confessed to painting it. He described the cloth as a product of cunningly painted artistry, a deliberate deception designed to exploit the faithful. This is, on the surface, the most damning evidence against the shroud's authenticity, a contemporary high-ranking church official alleging a direct confession from the forger. Yet the story is not so simple. The political and religious landscape was fractured, with rival popes vying for power. Geoffroy de Charny and his family had powerful connections to the Avignon papacy, and Pope Clement VII, despite d'Arcis's protests, ultimately issued a decree. He did not declare the shroud to be authentic, but rather he allowed its continued display as a representation of the true burial cloth. This subtle compromise permitted veneration to continue while sidestepping a definitive theological pronouncement, a political solution that saved face for all parties but left the fundamental question unanswered. So we are left with a deeply ambiguous historical debut. We have a pious knight presenting an object of immense power, a bishop alleging a proven fraud, and a pope authorizing its veneration for political expediency. This 14th century controversy sets the exact tone for the debate that would follow for the next 700 years. It encapsulates the central conflict between sincere belief and skeptical inquiry. If the shroud is genuine, its sudden appearance in France requires an explanation for its whereabouts during the missing 13 centuries since the crucifixion, a gap that proponents have tried to fill with theories about its journey from Jerusalem through Constantinople and into the hands of the Knights Templar. If it is a forgery, then it is a work of such staggering genius that it fooled millions at its unveiling and continues to defy full explanation by modern science. The stage was set in Liary, not with a whisper, but with a clash of faith, power, and accusation that echoes down to our own time. This brings us to the very heart of the mystery, the feature of the shroud that has left scientists utterly baffled for decades, the nature of the image itself. Forget everything you know about painting or printing. When researchers first placed samples of the cloth under powerful microscopes, they expected to find evidence of a medium pigment, ink, or dye. They found nothing of the sort. The straw-colored image of the man is not painted on the cloth at all. Instead, it is a phenomenon confined exclusively to the uppermost layer of the linen fibers. Imagine looking at a single thread from the shroud under extreme magnification. You would see that the coloring exists only on the very topmost 1/1000th of a millimeter thick crown of the thread. There is no penetration of any substance into the thread, nor is there any on the sides of the fibers. It's as if the threads were individually and very superficially toasted, but without any signs of charring or chemical alteration that would indicate a conventional scorch. This is a crucial point. The cellulose of the linen itself has undergone a chemical change, a dehydration and oxidation that has aged the fibers exactly where the image appears, creating a permanent straw-yellow discoloration. The mechanism that could achieve this is completely unknown in the world of art or forgery. No medieval artist, no matter how skilled, had a technology that could selectively age the very tips of individual linen threads to create a perfect, full-body negative image without any brush, pigment, or physical contact. This leads to the second, and perhaps even more mind-bending, property of the image. In the 1970s, a team of scientists performed a revolutionary analysis. They took the varying intensities of the image, the light and dark areas on the cloth, and fed this data into an advanced image analyzer, a device used at the time for interpreting satellite photographs and mapping planetary surfaces. The logic was that the intensity of the image on the cloth should correspond to something. What they discovered was nothing short of astonishing. The image's darkness, its intensity, was not random. It correlated perfectly with the distance that a three-dimensional body would have been from the cloth draped over it. Think of it this way. If you took a wet cloth and pressed it against a statue, the areas in direct contact would be darkest, while the areas that only hovered near the surface would be lighter. The Shroud of Turin encodes this exact kind of distance information. The tip of the nose, which would have been closest to the cloth, shows the darkest, most intense image. The eye sockets, which would have been recessed further away, are significantly fainter. Every contour of the body, the hands, the muscles of the chest, the hollow of the back, is mapped onto the cloth with a precise mathematical relationship between cloth to body distance and image intensity. This means the shroud contains a perfect, encoded three-dimensional map of a human form. This is a concept that was completely foreign to the medieval world. Artists of that era understood perspective in a two-dimensional sense, but the idea of encoding topographical, three-dimensional data onto a flat surface is a modern, 20th century concept born of computer imaging and photographic science. For a forger in the 1300s to have created this, they would have needed to not only invent a completely unknown chemical process to stain the cloth without contact, but they would also have needed to possess a sophisticated, subconscious understanding of three-dimensional data projection that wouldn't be formally understood for another 600 years. They would have had to precisely calculate how light and dark values should correspond to distance across a complex human form, and then execute this vision with a technique that left no brushstrokes, no pigments, and only affected the very surface of the threads. The sheer improbability of this is staggering. The image, therefore, stands as a paradox, a seemingly simple, faint imprint that, upon scientific investigation, reveals itself to be a product of a technology and a knowledge base that appears to be far beyond the capabilities of the time in which it first appeared in the historical record. It is this combination of inexplicable creation and encoded information that elevates the shroud from a curious artifact to a genuine, world-class enigma. For centuries, the faint, sepia-toned image on the shroud was viewed exactly as it appeared to the naked eye, a ghostly, almost abstract imprint of a human form. Its details were subtle, its features muted and difficult to discern with any real clarity. That all changed in one electrifying moment in the spring of 1898, an event that would catapult the shroud from a curious relic into the forefront of modern scientific inquiry. The city of Turin was hosting a major exposition to celebrate the 50th anniversary of the Italian Constitution, and as part of the festivities, the revered cloth was to be put on public display. To create a permanent photographic record of the event, an amateur photographer and local lawyer named Secondo Pia was granted an unprecedented privilege. He was allowed to take the very first photographs of the shroud. The conditions were challenging. Working in the dim, flickering light of the cathedral's Cappella della Sindone on the evening of May 28th, Pia set up his bulky camera and exposed 2 glass plate negatives for extended periods of time, one for 14 minutes and another for 20. The developed plates, he assumed, would simply provide a faithful copy of the faint, hard-to-see image on the ancient linen. What happened next would become the stuff of legend. Carrying the exposed plates back to his darkroom, Pia began the meticulous process of developing them. As the chemical bath slowly worked its magic on the first glass plate, an image began to emerge in the dim red glow of the safe light. But it was not the faint, ghostly figure he expected to see. Staring back at him from the developing tray was not a negative, but what appeared to be an incredibly detailed, lifelike positive portrait of a man. For a moment, Pia was so stunned he nearly dropped the plate, fearing he had made a catastrophic error and ruined the historic photograph. He quickly realized the truth was far more incredible. The image on the shroud itself, the one everyone had been looking at for centuries, was a natural negative. His photographic negative had, in the alchemy of the darkroom, cancelled out that negative quality, revealing the stunning positive image that had been hidden in plain sight all along. The transformation was absolute. The faint, shadowy stains resolved into the clear, three-dimensional features of a serene yet tortured male face with a commanding presence. The beard, the mustache, the long hair parted in the middle, all were now sharply defined. The wounds became vividly clear. The blood flows from the head, the piercing gaze from the eyes, the rigor mortis of the body. It was no longer just an imprint, it was a portrait. The impact of this discovery was immediate and profound. When Pia shared his results, the public and scientific communities were electrified. The photograph was reproduced in newspapers and journals around the world, allowing millions to see the face from the shroud for the first time with a clarity that was previously impossible. For believers, it was a moment of divine confirmation, as if a veil had been lifted to reveal the true face of Christ. For scientists and skeptics, it presented an enormous and confounding puzzle. This was no simple painting. The notion that a medieval forger would have the foresight, the understanding of optics, and the technical skill to create a perfect, seamless negative image, a concept completely unknown in the 14th century, was nearly impossible to comprehend. A forger would have painted a recognizable positive image. They would have had no reason and no conceptual framework to create an image that only made perfect sense when viewed as a photographic negative centuries before the invention of photography. Pia's accidental discovery fundamentally altered the trajectory of shroud research. It forced the world to confront the fact that this was not a straightforward object, but one that contained encoded information that could only be fully accessed and understood through the technology of a future age. The ghost had been given a face, and the mystery had been magnified 1,000-fold. To truly understand why this image is so compelling, we need to move beyond the cloth itself and look directly at the man it depicts. He is not a generic figure, he is a specific individual whose body tells a story of extreme and methodical torture. Forensic experts who have analyzed the image describe a man of impressive stature for the time, standing about 5 feet 10 inches tall and weighing roughly 170 pounds with a lean, muscular build. His hair is long, pulled back from the face and parted in the middle, falling to his shoulders, and he wears a full beard and mustache. His features are Semitic, consistent with a man from 1st century Judea. But it is the meticulous and brutal catalogue of injuries that has drawn the most intense scrutiny from pathologists and historians, creating a portrait of suffering that aligns with chilling accuracy to the Roman practice of crucifixion. Perhaps the most gruesome and extensive wounds are the scourge marks. Covering the man's back, buttocks, and the backs of his legs are over 120 distinct lesions. These are not random lash marks. Medical examiners have identified them as consistent with the Roman flagrum, a short whip with 2 or 3 leather thongs, each tipped with heavy pieces of lead or bone called scorpions. The pattern on the shroud shows dumbbell-shaped bruises and linear cuts, exactly matching the double lash impact of a 2-thonged whip, with the heavier tips causing the distinct dumbbell-shaped wounds. The sheer number of blows suggests a savage flogging, administered by 2 men striking from either side, a punishment so severe it was often fatal on its own. Then we come to the evidence of the crucifixion itself. The nail wounds are not where popular art often places them in the palms of the hands. The image on the shroud shows blood flows originating from the wrists, specifically through an area known as the space of destot. This is a critical anatomical detail. A nail driven through the palm would tear through the fragile metacarpal bones under the body's weight, and the victim would fall from the cross. Driving a spike through the wrist between the radius and ulnar bones and the carpal bones creates a secure anatomical lock that can support the full weight of a human body. This precise medical knowledge was completely lost after the Romans abandoned crucifixion and was only rediscovered by modern forensic pathologists. Similarly, the feet are shown as having been pierced by a single nail driven through both, with the left foot placed over the right. This is evidenced by a distinct blood flow that changes direction as it ran down the foot, suggesting the legs were bent at the knee and the feet were rotated inward, a position that would cause excruciating cramping in the thighs and lead to rapid asphyxiation. Another profound wound is visible on the right side of the chest. A large, elliptical stain of blood and a clear, watery fluid surrounds a severe puncture wound, measuring about 1 3/4 inches by 1/2 inch. The presence of this clear fluid, separated from the blood, is medically significant. Forensic pathologists and surgeons have identified this as a post-mortem flow of pericardial and pleural fluid, which would only occur if a sharp object like a Roman lancia or spear had penetrated the chest cavity and pierced the sac surrounding the heart. This matches the biblical account of a Roman soldier piercing Jesus' side to confirm his death, an act that would have released a flow of this distinct bodily fluid. Finally, we see the wounds to the head. The entire scalp is marked with numerous small puncture wounds from which streams of blood have flowed in a distinctive pattern. These flows do not run straight down the forehead, but instead trace a path around the sides and back of the head. This pattern is medically consistent with wearing a rigid cap of sharp thorns, which would have pierced the major superficial blood vessels in the scalp. The direction of the blood flows indicates that the man was upright for a considerable time after this wound was inflicted, and that his head was repeatedly moved forward and side to side, causing the blood to run in rivulets around the contours of his skull rather than straight down his face. Each of these forensic details, the wrist wounds, the foot position, the scourge marks, the side wound, and the cap of thorns, presents a level of anatomical and historical precision that would have been inconceivable for a medieval forger to fabricate. The artists and physicians of the 14th century had no access to Roman execution manuals or detailed forensic knowledge of crucifixion. They would have had no reason to place the nail wounds in the anatomically correct wrist location, nor would they have understood the physiological reason for the watery fluid from the side wound. The man in the shroud, therefore, stands as a silent but incredibly detailed witness to a very specific and brutally efficient form of ancient execution. By the late 1970s, the shroud had become an icon of mystery, a puzzle that photography and initial microscopic analysis had only deepened. The world needed answers, and science was poised to deliver them. This set the stage for a truly unprecedented event, a moment that would become known as the scientific trial of the shroud. In 1978, a dedicated team of American scientists and researchers, operating under the banner of the Shroud of Turin Research Project, or STURP, was granted a remarkable opportunity. For 120 consecutive hours, 5 full days and nights, they were given round-the-clock, exclusive access to the sacred cloth. Their mission was as ambitious as it was straightforward: to subject the shroud to the full battery of 20th century analytical technology, leaving no stone unturned in their quest to determine, once and for all, how the image was formed. This was not a group of religious pilgrims. It was a who's who of top-tier physicists, chemists, microbiologists, and photography experts from prestigious institutions like NASA, a Jet Propulsion Laboratory, and Los Alamos National Laboratory. They arrived in Turin with over 2 tons of the most sophisticated, cutting-edge equipment available, turning the Royal Chapel into a temporary high-tech laboratory. The atmosphere was charged with a palpable sense of anticipation. They were not there to prove or disprove a miracle. They were there to collect raw, empirical data, to let the shroud speak for itself in the unambiguous language of science. Their approach was meticulously comprehensive and entirely non-destructive. Not a single thread would be cut, and no chemicals would be applied to the cloth itself. Instead, they employed a suite of advanced imaging and spectroscopic techniques designed to probe the shroud's secrets from a distance. They used powerful macroscopes and microscopes to examine the weave and the image fibers at magnifications never before achieved, searching for any telltale sign of artistic technique. They employed raking light examination, shining light across the surface of the linen at a very low angle. This technique is exceptionally good at revealing surface topography, and it would have clearly shown any raised areas from applied paint, pigment, or any other substance. If the image was a painting, the raking light would reveal its texture. They turned to infrared spectrometry, a method that identifies chemical compounds by analyzing how they absorb infrared light. Different pigments, dyes, or organic substances have unique infrared fingerprints, and this tool would detect the presence of any medium used to create the image. Finally, they utilized ultraviolet fluorescence photography. When certain materials are exposed to UV light, they absorb that energy and re-emit it as visible light, a phenomenon known as fluorescence. Paints, varnishes, and even certain biological materials all have distinct fluorescent signatures. If the shroud's image areas had been treated with any foreign substance, the UV cameras would see it glowing back at them. As the team worked through days and nights, surrounded by the hum of their machinery and the watchful eyes of the world, every test, every scan, every photograph was a step closer to a verdict. This was the moment of truth, a confrontation between a 20th century scientific arsenal and a centuries-old enigma. The data was collected, the images were processed, and the team returned home to begin the painstaking, multi-year process of analysis. The scientific world held its breath, waiting for the conclusive report that would finally solve the mystery. When the Shroud of Turin research project finally released its official findings, the scientific community and the world at large were met with a conclusion that was both definitive and deeply puzzling. After thousands of hours of analysis employing the most advanced non-destructive testing methods available, the team of elite scientists reached a unanimous and startling verdict. They stated in no uncertain terms that they could find no evidence of forgery. The mysterious sepia image was not created by any form of paint, dye, stain, or pigment. Their exhaustive searches with infrared spectroscopy, ultraviolet fluorescence, and powerful microscopes found zero traces of any artistic medium. The team's official report included a now famous line that echoed through the decades. We can conclude for now that the shroud image is that of a real human form of a scourged, crucified man. It is not the product of an artist. This was not a statement of faith, but a declaration of empirical science. The blood, they confirmed, was real human blood, type AB, with the specific biochemistry of someone under extreme physical trauma. The image, however, remained a complete mystery, a superficial discoloration of the linen fibers that they could not explain, let alone reproduce. The core of their bafflement lay in the three fundamental properties of the image they could not reconcile with any known artistic or chemical process. First was its superficiality. The colorant exists only on the very topmost micron of the threads, with no capillary action drawing it deeper into the fibers, a phenomenon impossible to achieve with any liquid medium applied by hand. Second was its perfect uniformity. Under high magnification, the coloration is consistent across every single image fiber, with no directional brushstrokes, no pooling of liquid, and no variation in application. It appears as if each thread was individually and uniformly branded with the image. The third and most mind-bending property was its encoding of three-dimensional data. The darkness of the image corresponds precisely to the distance the cloth was from the body, a feature that has no precedent in the entire history of art. A painter creates light and shadow to simulate three-dimensionality on a flat surface. The shroud is a three-dimensional datum, a physical record of spatial relationships. In the years that followed, countless attempts were made in laboratories around the world to replicate the shroud's unique image. Researchers tried every conceivable method. They attempted contact scorching with heated bas-relief statues, but this produced a distorted, cartoony image where the entire area in contact with the statue burned uniformly, completely lacking the subtle, distance-coded gradations of the original. They experimented with various dry methods involving vapors and powders, but none could achieve the high-resolution, purely superficial staining of the shroud. They even theorized about some form of primitive photography using a camera obscura and light-sensitive salts, but this would have required technologies and chemical knowledge utterly unavailable in the medieval period, and it still wouldn't explain the perfect three-dimensional information. Every single attempt fell short. The shroud's image remained and still remains a unique artifact in human history. The STURP team, a group of hard-nosed, skeptical scientists who began their investigation with the explicit goal of uncovering a forgery, were ultimately left not with an answer, but with a profound and humbling admission of ignorance. They had taken the mystery apart piece by piece, only to find that the pieces themselves formed a picture far more complex and inexplicable than anyone had imagined. With the physical and chemical properties of the shroud presenting such a profound riddle, the investigation naturally expanded beyond the cloth itself, reaching into the very dust that had settled upon it over the centuries. This line of inquiry was pioneered by a man named Max Frey, a Swiss criminologist and botanist who was already famous for his work using pollen analysis to solve criminal cases. In 1973, and again during the 1978 examination, Frey was given a unique opportunity. Using a method standard in forensic science, he carefully pressed strips of sticky tape onto the surface of the shroud, lifting off not just linen fibers, but also microscopic particles that had become trapped in the weave over hundreds of years. Among this dust, he hoped to find a hidden history book written in the language of pollen grains. pollen is an incredibly durable and identifiable microscopic particle. Each plant species produces pollen with a unique shape, and these grains can survive for thousands of years. By identifying the types of pollen present on an object, a palynologist, a pollen expert, can effectively map out the geographical journey that object has taken, pinpointing the specific regions where it has been exposed to the open air. After years of painstaking analysis, Max Frey made a stunning announcement. He claimed to have identified 58 different species of pollen on his tape samples. Of these, he asserted that a significant number came from plants that grow only in a very specific area, the region around Jerusalem. These included species like the tumbleweed Gundelia tournefortii and the desert bean Cercis siliquastrum, plants native to the Holy Land. Furthermore, the combination of pollen types pointed overwhelmingly to a springtime exposure, as the plants represented would have all been in bloom simultaneously around March and April. For those who argue for the shroud's authenticity, this was a bombshell. It seemed to provide the hard, scientific evidence for a Middle Eastern origin that the historical record lacked, directly placing the cloth in 1st century Judea, right in the correct season for the crucifixion. Frey even claimed to have found pollen from plants specific to Constantinople and the areas of Edessa and Anatolia in modern-day Turkey, seemingly tracing the very path that tradition says the shroud traveled before arriving in Europe. However, like every other aspect of this enigma, the pollen evidence is far from settled science and has been mired in intense controversy. The first and most significant critique revolves around Max Frey's methods and the chain of custody of his samples. Frey worked largely alone, and his original tape samples were stored in his personal laboratory. After his death in 1983, other scientists questioned whether his samples could have been contaminated. Pollen is ubiquitous and can easily be transferred from one surface to another, or even through the air. Skeptics argued that without a strictly controlled, sterile environment during both the collection and the analysis, the pollen grains could have come from anywhere, including from Frey's own laboratory or from later exposure in Europe. The second major criticism challenges his identifications. Some palynologists who later examined Frey's data and a limited number of his prepared slides disputed his classifications, arguing that some of the pollen grains he identified as unique to Jerusalem could, in fact, be found in other parts of Europe or the Mediterranean basin. They pointed out that the distinctive Gundelia tournefortii pollen, a cornerstone of his argument, has since been identified in archaeological sites in Mesopotamia and Egypt, widening its possible range. The debate over the pollen encapsulates the entire shroud dilemma, a piece of evidence that, to its proponents, is a compelling and logical piece of a larger puzzle, and to its detractors is an unrepeatable finding from a compromised source. The scientific community remains divided. Later studies have attempted to reanalyze the dust from the shroud, with some confirming the presence of Middle Eastern pollen and others finding a predominance of European types, which would be expected for an object housed in France and Italy for 600 years. What the pollen evidence ultimately provides is not a verdict but a tantalizing hint. It suggests a story that aligns perfectly with the shroud's traditional history, a narrative of a journey from Jerusalem to the West. Yet, because the initial analysis is so difficult to fully verify, it stands as a ghost of a proof, a clue that points strongly in one direction but lacks the uncontestable authority to close the case. It adds another layer of profound complexity, suggesting that even the microscopic world clinging to the shroud's threads is part of its enduring and deeply contested mystery. After years of mounting scientific curiosity and intense public speculation, the stage was set for what was widely anticipated to be the final, definitive test. By the late 1980s, the debate over the Shroud of Turin had reached a fever pitch. The world had heard the compelling forensic evidence and the baffling conclusions of the STURP team, which declared the image unexplainable by any known artistic method. Yet the fundamental question of age remained unanswered. Was this cloth truly ancient, dating back to the 1st century, or was it a medieval creation as the Bishop of Troyes had alleged 600 years earlier? The technology to answer this question with remarkable precision now existed: radiocarbon dating. This method measures the steady decay of carbon-14, a radioactive isotope found in all living things. Once an organism dies, it stops absorbing carbon-14, and the existing amount begins to diminish at a known rate. By measuring the remaining carbon-14 in a sample of linen, scientists could calculate with a small margin of error the approximate year the flax plants used to make the cloth were harvested. For the shroud, this meant a simple binary outcome. A date around the 1st century would shatter the forgery theory, while a date from the Middle Ages would seemingly confirm it. The pressure on the Catholic Church, which now served as the shroud's custodian, was immense. After extensive and careful negotiation with scientific authorities, the Vatican gave its official permission. The mystery of the ages would be settled by the impartial, cold logic of atomic physics. The planning for this historic event was a masterpiece of scientific rigor and protocol, designed to eliminate any possible doubt about the results. A committee of experts devised a meticulous, multi-stage process that was as much about ensuring credibility as it was about obtaining a date. The first and most critical step was the selection of the sample site. The team chose a single, remote location on the shroud, a small, unassuming corner area near the edge, well away from the main body image, the scorched areas from a fire in the 1500s, and any obvious patches or water stains. This spot was chosen specifically because it was believed to be one of the most pristine and uncontaminated parts of the entire textile. On the morning of April 21, 1988, in a tense and solemn ceremony within the sacristy of Turin Cathedral, a small group of officials and scientists gathered. With the world's media waiting outside, a textile expert carefully cut a single postage stamp-sized piece of linen from the designated corner. This one sample was then divided into 3 smaller segments, each destined for one of 3 world-renowned radiocarbon dating laboratories: the University of Oxford in England, the University of Zurich in Switzerland, and the University of Arizona in Tucson, United States. The use of 3 separate, independent labs was a crucial part of the protocol. It was a built-in system of cross-verification. If all 3 labs, using their own equipment and their own teams, returned the same date, the result would be considered unimpeachable. To ensure the integrity of the test was beyond reproach, the process included a final, brilliant layer of scientific blindfolding. Along with the 3 known shroud samples, the committee provided each laboratory with 3 control samples of known age. These were small pieces of cloth from other archaeological textiles whose provenance and dates were firmly established but were unknown to the testing labs. One control was from a funerary cloth from an Egyptian tomb dating to the 11th or 12th century. Another was from a textile found in a Nubian site dated to around the 5th or 6th century. And a third was a piece of linen from a cloak belonging to Louis IX, the French king and saint who died in the 13th century. All the samples, both the shroud fragments and the controls, were packaged in identical, coded containers. The scientists at Oxford, Zurich, and Tucson would have no idea which sample was which. They were simply tasked with reporting the age of each numbered sample they received. This double-blind method was the gold standard of scientific testing, designed to prevent any unconscious bias from influencing the results. The samples were dispatched and an anxious silence fell over the world. For months, the 3 labs worked in isolation, meticulously cleaning their samples, converting the linen to pure carbon, and counting the remaining carbon-14 atoms. The wait felt interminable. After centuries of debate and decades of modern analysis, the answer was now sealed inside those anonymous, numbered containers, soon to be revealed by the most trusted timekeeper science had ever devised. The moment of truth arrived in the autumn of 1988, and the result was a shockwave that reverberated around the globe, seemingly shattering centuries of mystery into a single mundane fact. The three independent laboratories, Oxford, Zurich, and Arizona, had completed their analyses, and their findings were unanimous. With a 95% confidence level, they concluded that the flax plants used to create the linen of the Shroud of Turin were harvested between the years 1260 and 1390. For the world, and especially for those who had invested their faith in the cloth's ancient origins, this was a devastating blow. The radiocarbon date placed the shroud's creation squarely in the High Middle Ages, a period from the mid-13th to the late 14th century. This timeline aligned with chilling precision to the cloth's first undisputed historical appearance in Liège, France, around the 1350s. It was a perfect match. To the vast majority of scientists and skeptics, the case was closed. The shroud was not the burial cloth of Jesus. It was a medieval artifact, a brilliant and devout forgery created in the very era that Bishop Darcis had described, an object designed to inspire pilgrimage and veneration in an age hungry for tangible connections to the divine. The headlines were triumphant and final. Science debunks the Shroud of Turin. Carbon dating proves relic a fake. It appeared that the atomic clock had spoken, and its verdict was unforgiving. The enigmatic image, the forensic details, the inexplicable properties, all of it was now, it seemed, simply evidence of an unknown medieval artist's unparalleled and previously unsuspected genius. For a time, this conclusion settled over the debate like a heavy blanket, stifling further inquiry in the mainstream scientific community. The radiocarbon test was, after all, the gold standard of archaeological dating. It had been conducted with impeccable protocols by the world's top labs, and their results were in perfect agreement. The logic felt unassailable. How could a cloth woven from flax harvested in the 1300s have wrapped a man who died in the 1st century? The answer seemed self-evident: it couldn't. The shroud was demoted in the public imagination from a profound mystery to an elaborate, albeit fascinating, hoax. The burden of proof had decisively shifted onto the shoulders of those who still believed in its authenticity. They now had to challenge not a bishop's 600-year-old accusation, but the most trusted dating technique in modern archaeology. It was a seemingly impossible task, one that required finding a flaw in a nearly flawless scientific process or presenting a compelling reason why the tested sample might not be representative of the entire cloth. In the years immediately following the announcement, the narrative was dominated by this apparent finality. The mystery of the shroud, it seemed, had been solved not by theologians or historians, but by physicists and chemists counting the faint, decaying whispers of carbon atoms. The ghost had been given a birth certificate, and it was disappointingly recent. Yet, the story did not end there. For many scientists, historians, and believers, the radiocarbon date felt less like a definitive answer and more like a piece of a puzzle that simply did not fit with the rest of the picture. How could a medieval forger working in the 1300s have created an image with properties that 21st century science still cannot adequately explain? How could they have possessed such an intimate, lost knowledge of Roman crucifixion practices? This profound disconnect fueled a relentless search for an alternate explanation, a reason why the carbon dating might be misleading. The most prominent and scientifically rigorous challenge came from an unexpected source: Dr. Raymond Rogers, a retired Los Alamos National Laboratory chemist who had been a senior member of the original STURP team. Rogers, a fiery and independent-minded scientist, re-entered the fray with a specific and startling hypothesis. He became convinced that the single sample cut from the shroud's corner in 1988 was fundamentally unrepresentative of the entire cloth. His investigation led him to a radical conclusion. The tested area was not part of the original 1st century shroud at all, but rather an expertly and invisibly repaired section, a medieval patch woven in to replace damaged material. Rogers's theory, often called the invisible reweave hypothesis, was not based on mere speculation but on a meticulous re-examination of evidence that others had overlooked. He focused on archived photographs and specific tape samples taken by the Sturp team in 1978 from the exact same corner that would later be used for the carbon dating. His analysis revealed a critical clue: the presence of a coating of madder root dye and a gum binder, substances used in a specific dyeing technique common in the medieval period. This dye was found coating the threads in the sampled area. However, when Rogers examined threads from the main body of the shroud, taken from areas adjacent to the scorch marks of the 1532 fire, he found something completely different. Those core samples contained no trace of madder dye or gum. Instead, they were coated with a very thin layer of a carbohydrate polysaccharide coating, a simple starch or sucrose layer that was sometimes used to finish linen in the ancient world. The chemical divide was absolute and telling. The corner sample and the main cloth had entirely different chemical histories. Rogers argued that this corner section had been skillfully repaired at some point before the shroud's first documented appearance in the 1350s. Textile conservators, using a technique known as invisible reweaving, would have taken new threads and dyed them to match the aged color of the original cloth, then woven them seamlessly into the damaged area to restore the textile's structural integrity. This was a common and respectable practice for preserving valuable relics. The problem, Rogers contended, was that the 1988 sampling committee had no knowledge of this repair. They believed they were cutting from a pristine, original section. In reality, they were cutting a sample that was composed of a mixture of original 1st century threads and these much newer medieval repair threads. When this hybrid sample was burned and tested, the overwhelming presence of the young carbon from the repaired threads effectively swamped the faint, ancient carbon signal from the original linen, pulling the average date forward into the 13th and 14th centuries. Rogers's own calculations suggested that if the sample contained as little as 35 to 40% modern cotton, a common fiber for medieval repairs, it would be enough to produce the medieval dates that were announced to the world. His work provided a plausible, scientifically grounded reason for why the carbon date might be a red herring, an analysis not of the shroud itself, but of its later medieval restoration. Beyond the reweaving theory, other compelling hypotheses for the skewed date have been put forward, each focusing on different forms of contamination. One major event in the shroud's history is the fire of 1532 in the Sainte-Chapelle in Chambéry, France. The silver reliquary holding the folded cloth partially melted, and a drop of molten silver burned through dozens of layers, creating the series of symmetrical scorch marks and holes visible today. The nuns of Chambéry patched these burn holes, but to extinguish the smoldering cloth, it was doused with water. The intense, localized heat from this event could have had a significant chemical impact. Some researchers propose that the fire essentially cooked the linen, driving off volatile contaminants but potentially bonding the cloth with newer carbon isotopes from the smoke-filled environment or from the water used to douse the flames. Carbon dating measures the isotopic ratio in the material itself, and if that material has been chemically altered to incorporate newer carbon atoms, the date will be skewed younger. Laboratories do have protocols to clean samples of such contaminants, but critics argue that the complex, unknown chemistry resulting from such a unique thermal event could have created a form of contamination that the standard cleaning methods of the 1980s could not entirely remove. Another fascinating line of inquiry involves the biological environment of the cloth. The shroud has been handled by countless people over centuries, and it has been displayed openly to vast crowds. It would have accumulated a vast and complex ecosystem of microscopic life. Researchers like Dr. Leoncio Garza Valdez, a microbiologist, have proposed that an invisible, modern-looking biofilm of bacteria and fungi coating the linen threads could have contaminated the sample. These microorganisms secrete a protective layer of polysaccharides and other biological materials. Over centuries, this living biofilm, which contains modern carbon, could have become integrally bound to the ancient linen fibers. Like the reweaving theory, this bioplastic coating would introduce a layer of newer carbon that, when burned and tested, would make the underlying linen appear hundreds of years younger than it truly is. While the carbon dating labs did perform standard cleaning processes, which involve harsh chemicals to remove such organic contaminants, proponents of this theory argue that a centuries-old, robust biofilm might have been impossible to remove completely without destroying the sample itself, meaning a layer of modern carbon was still baked into the measurement. Each of these challenges, the invisible reweave, the fire contamination, and the microbial biofilm, undermines the perceived infallibility of the 1988 test. They suggest that the shroud is not a simple object to date. It is a complex historical artifact with a turbulent life, and the sample taken from its edge may have carried a much more recent and misleading chemical signature than anyone could have anticipated. The carbon date, rather than being the final word, became the starting pistol for a new and even more intricate phase of the debate. The year was 1532, and the shroud was housed not in Turin, but within the fortified Sainte-Chapelle in Chambéry, a city nestled in the French Alps. This chapel served as the private worship space for the Dukes of Savoy, the powerful family who had become the shroud's guardians. The cloth was kept securely folded within an elaborate silver gilt casket, locked away in a niche behind the main altar. But on the night of December 4th, a catastrophic fire broke out within the chapel. The exact cause remains unknown, but the flames spread rapidly, feeding on the wooden interior and the devotional objects within. The intense heat became focused on that silver reliquary. As the temperature soared, the casket did not just get hot, it began to melt. A drop of molten silver, heated to nearly 1,000 degrees Fahrenheit, dripped from the lid and burned directly through the layers of the folded linen inside. This single, searing drop created a series of the now famous, symmetrical scorch marks and holes that are visible on the shroud to this day. The fire was so severe that it threatened to completely consume the relic. In a desperate act of salvation, a quick-thinking cleric or firefighter reportedly used a halberd, a combination spear and battle axe, to smash through the protective iron grating and retrieve the glowing hot casket from the inferno. It was then doused with water to extinguish the smoldering cloth, an act that saved the shroud from total destruction, but may have introduced another layer of complexity to its already mysterious history. The damage was extensive but not fatal. The Poor Clare nuns of Chambéry, an order renowned for their skill in textile conservation, were entrusted with the painstaking task of repairing the holy relic. They set to work with incredible patience and artistry. To stabilize the cloth, they carefully patched the burn holes by backing the entire shroud with a large piece of fine Holland cloth, a sturdy reinforcement that is still in place today. Then they turned to the most visibly damaged areas, the 16 large holes created by the molten silver and the scorched linen surrounding them. Using a technique known as invisible reweaving, the nuns cut small, triangular patches from a piece of linen that was a close, though not perfect, match to the original. They then meticulously stitched these patches into place, seamlessly integrating the new fabric with the old. While their work was masterful for its time, the passage of centuries has made these repairs more visible. The patch cloth has aged differently than the shroud itself, creating the distinct, lighter-colored triangles that modern viewers can clearly see. For nearly 500 years, these patches served as a silent testament to the shroud's brush with oblivion, a permanent scar from one of the most dramatic events in its long and turbulent life. This historical drama, however, is far more than just a compelling story of survival. It sits at the very center of one of the most heated scientific debates surrounding the shroud, the controversy over its radiocarbon age. Researchers who question the medieval date from the 1988 tests point to the Chambéry fire as a potential catalyst for massive chemical contamination. Their argument hinges on the unique and powerful effects of intense, localized heat on organic materials like linen. Linen, being a plant-based fiber, is composed primarily of cellulose. When subjected to the kind of extreme heat generated by the fire and the molten silver, the molecular structure of that cellulose can be fundamentally altered. The intense thermal energy can drive off volatile compounds and break down certain chemical bonds, but it can also cause new ones to form. Crucially, the fire would have filled the air with smoke, a complex aerosol containing vast quantities of soot, which is pure carbon, along with other particles and gases. This smoke, rich in newer carbon isotopes from the burning wood and other materials in the chapel, could have been chemically bonded to the shroud's linen fibers by the heat, essentially baking a layer of modern carbon onto and into the ancient threads. Furthermore, the act of dousing the superheated reliquary with water could have amplified this effect. The sudden, violent cooling creates a powerful wicking action, much like pouring water on hot coals creates steam. This thermal shock could have drawn water-soluble contaminants and carbon particles from the smoke deeper into the microscopic structure of the fibers, locking them in place. The carbon dating process relies on measuring the ratio of radioactive carbon-14 to stable carbon isotopes in a sample. If that sample has been contaminated with a significant amount of newer carbon from an event like the Chambéry fire, carbon that is chemically bonded to the sample and not easily removed by standard pre-test cleaning methods, then the resulting date will be skewed dramatically younger. The laboratories in the 1980s used robust chemical cleaning processes, but critics argue that contamination from a unique, high-energy thermal event could have created a type of chemical bond that their protocols were not designed to fully strip away. In this scenario, the tested sample wasn't dating the original 1st century flax, but was instead measuring a complex mixture of the original linen and a layer of carbon deposited in the 1600s, pulling the average result forward into the medieval period and creating the apparent contradiction between the carbon date and the wealth of other historical and scientific evidence. The fire, therefore, is not just a footnote in the shroud's history. For many, it is the key that potentially unlocks the entire dating controversy, turning a seemingly definitive scientific result into a question mark shaped by flame and water. Given the profound and unexplained nature of the shroud's image, it was perhaps inevitable that a global cottage industry of replication would emerge. Scientists, artists, and dedicated hobbyists have taken up the challenge, attempting to answer the question, how was it done? By trying to do it themselves, but restricted to the materials and knowledge available in the 14th century. The results of these decades of experimentation are both fascinating and telling, for they consistently highlight the same stubborn truth. While one can mimic certain isolated features, no one has ever managed to recreate the Shroud of Turin in its entirety, capturing all of its unique and confounding characteristics in a single, unified process. One of the earliest and most intuitive theories involved contact scorching. The idea is straightforward. Take a heated, three-dimensional object like a bas-relief statue of a human form. Press a piece of linen against it, and the heat would burn an image onto the cloth. Researchers, including the physicist John Jackson, who was instrumental in the three-dimensional analysis, have conducted rigorous tests using this method. They created detailed bas-reliefs and heated them to various temperatures before carefully pressing linen over the surface. The results do produce an image, but it is a crude and distorted caricature of the shroud. The problem is one of physics. In a contact scorch, the areas in direct contact with the hot surface burn uniformly dark, while areas that are just a millimeter away receive virtually no thermal transfer. This creates a high-contrast binary image, dark where touched and blank where it did not, completely lacking the delicate, continuous tone gradations of the original. The shroud's image displays a perfect, seamless variation in intensity, from the dark tip of the nose to the faint hollows of the cheeks, a feat impossible to achieve with a simple heated object pressed against a cloth that would have inevitably draped and wrinkled, creating a blotchy, unrealistic impression. Furthermore, this method often produces a halo effect around the direct contact points and fails to achieve the extreme superficiality of the image, typically scorching deeper into the fiber threads. Another avenue of exploration involved chemical methods, specifically the use of vapors or reactive gases. The theory here posits that a medieval forger could have created a life-sized, relief-like platform of a human body, perhaps out of stone or wood, applied a reactive chemical to the cloth, and then draped it over the form. Through a slow chemical reaction, perhaps accelerated by sunlight or warmth, an image would develop. Experiments using vapors from ammonia or other compounds, or even applying a thin layer of myrrh and aloes substances mentioned in the biblical accounts of Jesus' burial, have been attempted. While some of these methods can produce a faint straw-yellow discoloration on linen, they consistently fail on multiple fronts. The images they create are blotchy and lack the high-resolution detail of the shroud, from the individual strands of hair to the pores of the skin. They also struggle with the uniformity issue. The coloration tends to be uneven, pooling in some areas and fading in others, and it often penetrates too deeply into the fibers, unlike the shroud's image, which resides only on the very crown of each thread. Most crucially, none of these chemical experiments have successfully encoded the precise three-dimensional distance information. The resulting image is flat, a simple stain without the topographical data that makes the shroud so unique. Perhaps the most technologically ambitious theory is the notion of a medieval photograph, proposed by the artist Nicholas Allen. This hypothesis suggests that the shroud is the world's first photograph. The theory posits that a forger could have constructed a massive camera obscura, a dark room or box with a small lens or pinhole, and placed a linen cloth coated with a light-sensitive substance such as silver nitrate inside. A corpse, or perhaps a live model covered in a phosphorescent powder, would be positioned outside, and its image would be projected by sunlight onto the treated cloth over a long exposure. On the surface, this idea is compelling because it explains the negative image and the apparent optical properties. However, this theory collapses under the weight of historical and practical impossibilities. First, there is not a single shred of historical evidence, no manuscript or sketch, that indicates anyone in the 13th or 14th century understood the principles of photography or possessed the required chemicals. Silver nitrate's light-sensitive properties were not documented until the 16th century. Second, the technical hurdles are monumental. Creating a lens large and precise enough to project a flawless, life-sized, high-resolution image of a human body, and then maintaining that projection stable for an exposure lasting many hours, is a feat that would challenge modern engineers. Any movement of the sun would distort the image catastrophically. Finally, and most decisively, this method still fails to explain the shroud's most baffling feature, the perfect encoding of three-dimensional data. A photograph, whether medieval or modern, captures light and shadow based on the reflectivity and color of a subject, not its precise distance from the film plane. In a photograph, a recessed eye socket might be in shadow, but it would not have a mathematically precise, lighter intensity directly correlated to its millimeter-perfect distance from the camera lens. The shroud's image behaves not like a photograph, but like a topographical map generated by a body-scanning laser. What becomes clear after surveying this long history of failed replication is the sheer cumulative improbability of a medieval forgery. Each attempt can, at best, solve one piece of the puzzle while utterly failing at the others. A bas-relief scorch can create a superficial image, but without the three-dimensional data or the resolution. A chemical vapor might create a faint stain without pigments, but it lacks detail and distance encoding. The photography theory accounts for the negative image but requires wholly anachronistic technology and still doesn't explain the three-dimensionality. The shroud, by contrast, possesses all of these properties simultaneously. For a single medieval artist to have accomplished this, they would have needed to be a master sculptor, a brilliant chemist with knowledge of substances and reactions unknown for centuries, a pioneering optician and physicist who understood concepts of optics and data projection that wouldn't be formalized for 600 years, and a flawless executor who left behind not a single mistake. Brushstroke or trial piece, they would have had to combine 4 or 5 different impossible technologies into one seamless process, and then take that secret to their grave, leaving no record of their world-altering genius. The continued global failure to replicate the shroud using any known medieval method does not prove it is authentic, but it does powerfully underscore its status as a unique and profound anomaly. It stands as a silent, enduring challenge to our understanding of history and human capability, a relic that seems to defy the very timeline to which it has been assigned. So we have a cloth that science cannot explain and a date that history cannot easily accept. But there is another element woven into the fabric of the shroud, one that is stark, visceral, and impossible to ignore: the blood. While the faint sepia body image remains a chemical ghost, the darker stains that mark the wounds are something entirely different, something tangible. During their exhaustive examination in 1978, the scientists of the Shroud of Turin research project turned their most powerful tools toward these dark patches. Using a technique called reflectance spectroscopy, they analyzed the specific way light interacted with these stains. The results were unambiguous. The spectra they obtained were a perfect match for oxidized, decomposed hemoglobin, the iron-rich protein that carries oxygen in our red blood cells. This wasn't a guess, it was a chemical fingerprint. Furthermore, their tests revealed the presence of other key components of whole blood, including bilirubin, a compound released when blood cells break down, and albumin, a primary protein in blood serum. The forensic conclusion was clear and has withstood decades of scrutiny. The stains on the Shroud of Turin are not red paint, not ochre pigment, not any form of artistic simulation. They are the real, physical residue of human blood. This blood evidence adds another profound layer of authenticity to the man's suffering. The flows from the scalp, for instance, have a very specific, serrated appearance, which pathologists note is consistent with blood flowing from scalp wounds matting the hair and being rerouted along its strands, a detail a forger would be unlikely to know or depict. Even more telling, when researchers examined the areas where bloodstains and the body image overlap, they found a critical sequence. The blood was on the cloth first. The faint body image lies underneath the bloodstains in these areas. This means that whatever mysterious event created the image of the man occurred after his blood had already soaked into the linen. This sequence of events fits perfectly with the historical narrative of a body being wrapped in a burial cloth after death, with the image forming later, but it creates a monumental problem for any forgery theory. A medieval painter would have had to first apply real human blood in anatomically perfect patterns, let it dry, and then somehow create the inexplicable body image over and around it without disturbing the blood crusts or using any medium that would be detectable. A practical impossibility. Delving deeper into the blood's chemistry, researchers made another intriguing discovery. The blood on the shroud was identified as type AB positive. This is a common blood type among Jewish populations in the Middle East, both historically and today, which adds a compelling geographical and ethnic consistency to the narrative. Some analyses have even reported the presence of elevated levels of bilirubin, which can be a sign of someone who endured extreme physical trauma, as bilirubin is released in large quantities when the body is under severe stress and breaking down red blood cells rapidly. However, this is where the scientific certainty begins to transition into a much more profound and ultimately unanswerable question. we can know with a high degree of confidence that the blood is real human blood from a tortured individual. We can know its type, we can see that its placement is forensically accurate, but here we reach the absolute limit of what science can tell us. What test, what instrument, what analysis could ever possibly prove that this particular blood belonged to one specific man who walked the earth 2,000 years ago? There is no DNA database from the 1st century, no genetic sample from a known relative for comparison. Even if a pristine DNA sample could be extracted from the shroud, a highly controversial and technically challenging prospect, it could tell us about the man's ancestry and perhaps his physical characteristics, but it could never, ever provide a certified name. The blood on the shroud presents us with a powerful, tangible connection to a human tragedy, but it simultaneously underscores the fundamental chasm between empirical evidence and historical identification. We are left with a compelling, even breathtaking convergence of evidence, but not a scientific proof of identity. The blood is real, the suffering was real, but the name of the victim is a question that forever lies outside the reach of a microscope or a spectrometer, residing instead in the realms of history, tradition, and faith. Yet the story of the burial cloths does not end in Turin. Far to the west, in the Cathedral of Oviedo in northern Spain, rests another ancient and deeply venerated relic, one that provides a potentially explosive piece of corroborating evidence. This is the sudarium of Oviedo, a much smaller, unassuming piece of linen, measuring only about 34 by 21 inches. Unlike the shroud, it bears no mysterious body image. Instead, its entire story is written in stark, brownish bloodstains. Tradition holds that this is the sudarium, the face cloth mentioned in the Gospel of John, which was placed over the head of Jesus after his death, likely to control the considerable bleeding while the body was being transported from the cross to the tomb. While the shroud presents a grand, full-length enigma, the sudarium offers a more focused but no less profound forensic narrative. Its historical documentation is remarkably solid. We can trace its journey with considerable confidence from Jerusalem to North Africa after the Persian conquest in the 7th century, then across the Strait of Gibraltar to Spain, where it has been safeguarded in Oviedo since the 8th century. This well-established provenance gives it a historical footprint that predates the shroud's clear emergence in 14th century France, anchoring it firmly in the ancient world. The true fascination begins when we place these two cloths in a forensic conversation. Researchers have undertaken a meticulous comparative analysis, and the results are nothing short of staggering. First, there is the matter of blood. Laboratory analysis has confirmed that the stains on the sudarium are, like those on the shroud, human blood. More specifically, the blood type on both cloths is an exact match, type AB. While this blood type is not unique, the statistical coincidence of two separate ancient relics from different geographical locations and historical traditions, sharing the same rare blood type, is at the very least a remarkable and compelling detail. But the connection runs far deeper than a simple blood match. The stain patterns on the sudarium tell a clear and brutal story of their own. The cloth shows a complex series of stains that forensic pathologists have interpreted as coming from two distinct sources: pulmonary edema fluid, which is a frothy mixture of air, blood, and fluid from the lungs that can be expelled after death, particularly in cases of traumatic asphyxiation like crucifixion, and the direct flow from wounds on the head. This is where the link to the shroud becomes almost unnervingly precise. When the stain patterns on the sudarium are analyzed, they correspond perfectly to the head of a man who was in multiple specific positions. The primary stains indicate the cloth was first placed over the head while the body was upright, perhaps just after being taken down from the cross. Then the pattern shifts, showing the man was laid on his back for a period, and finally that the body was turned onto its side. This sequence of movements aligns perfectly with the journey from cross to tomb. Now, if you take these precise stain patterns from the sudarium and superimpose them, both physically and digitally, onto the facial image of the Shroud of Turin, they align with an almost lock and key perfection. The blood flows from the scalp visible on the shroud. Those rivulets from the cap of thorns fit exactly within the stained areas of the sudarium. The wound in the side, as depicted on the shroud, aligns with the area on the sudarium that would have been stained by the pulmonary fluid when the body was turned onto its side, allowing fluid from the chest wound to flow out through the nose and mouth and onto the face cloth. The two cloths appear to be telling different parts of the very same story at sequential moments in time. The sudarium was likely the first cloth used, placed over the head to manage the bleeding immediately after death and during transport. Then, at the tomb, this face cloth would have been removed before the body was wrapped in the full-length shroud, accounting for the clear blood stains that had already soaked into the linen before the mysterious body image formed. The correlation is so detailed and so forensically coherent that it stretches coincidence to its breaking point. It suggests with powerful and unsettling force that these two ancient cloths, separated by geography and tradition, may have once covered the very same individual. This brings us to the ultimate, unanswerable question that lies at the intersection of faith and physics. If the shroud is indeed authentic, then the man wrapped within it was not merely a tragic victim of crucifixion. According to Christian belief, he was Jesus of Nazareth, who 3 days after his death was resurrected from the dead. This core tenet of Christianity transforms the shroud from a forensic artifact into a potential theological document. The scientific data we've explored, the lack of decomposition, the absence of any artistic medium, and the inexplicable nature of the image, suddenly finds a possible, albeit miraculous, context. Could the very process that formed the image be directly linked to the event of the resurrection itself? This line of thinking has led to what is perhaps the most daring and scientifically provocative hypothesis for the shroud's creation, the radiation burst theory. The logic of this theory begins by addressing two of the most stubborn forensic puzzles simultaneously. First, the blood on the cloth is intact and shows clear serum halos, indicating the body was not forcibly removed from the linen wrappings. If the cloth had been unwrapped from a decomposing body days later, these precise crusted bloodstains would have been smeared, disturbed, or broken. Second, and even more baffling, there are no signs of bodily decomposition on the shroud. When a body begins to decompose, fluids and gases are released that would have left clear, blotchy stains on the surrounding cloth, completely obliterating the delicate, high-resolution image we see. The image we have is of a pristine, intact body that simply and mysteriously left its imprint behind without any evidence of physical decay or violent separation. To reconcile these facts, some scientists have proposed that the body must have dematerialized in a way that did not involve physical movement through the cloth, and that this dematerialization was accompanied by a massive, instantaneous release of energy. This is where the radiation burst theory takes shape. The primary proponent of this idea is Dr. John Jackson, the same physicist who first discovered the shroud's encoded three-dimensional data. Jackson and others have suggested that at the moment of resurrection, the body was transformed, and in that transformation, a brief, directional burst of energy, likely in the form of proton radiation or ultraviolet light, emanated from every point within the body, projecting outwards perpendicular to the skin's surface. This energy would have acted like a form of radiation, branding, or a sophisticated form of scorching. Because the energy would have traveled in straight lines, its intensity on the cloth would have been inversely proportional to the distance it traveled. The tip of the nose, being closest to the cloth, would have received the most intense dose of energy, causing a greater chemical change and a darker image. The recessed eye sockets further away would have received a much weaker dose, resulting in a fainter imprint. This perfectly explains the shroud's most confounding feature: its precise mathematical encoding of three-dimensional distance information. The image is essentially a perfect, life-sized radiograph of a human form, created by a momentary, body-shaped flash of energy. Furthermore, this type of radiative process could account for the image's extreme superficiality. The burst of energy was so brief and of such a specific wavelength that it only affected the very topmost crowns of the linen threads, dehydrating and oxidizing the cellulose fibers to create that straw yellow color, but without the prolonged heat necessary to cause charring or to burn deeper into the fabric. It was a flash of light so pure and so powerful that it altered matter at a microscopic level, leaving behind a perfect photonegative representation of its source. Scientists who support this model point out that attempts to replicate aspects of the image using excimer lasers, which produce short pulses of ultraviolet light, have yielded superficial, shroud-like discolorations on linen, providing a small-scale laboratory parallel to this monumental proposed event. The theory, while extraordinary, provides a single, elegant mechanism that explains the negative image, the three-dimensional data, the superficial staining, and the lack of body decomposition, all while being consistent with a moment of profound transformative power. Of course, this hypothesis exists at the very frontier of science and ventures directly into the realm of the miraculous. Critics are quick to point out that no known natural phenomenon can produce such a focused, full-body burst of radiation. The amount of energy required would be immense, and the idea that it could leave behind such a detailed, stable image without utterly incinerating the cloth is, from a conventional physics standpoint, fantastical. The radiation burst theory does not so much solve the mystery as it relocates it, moving the enigma from the question of how did a medieval artist do this, to what cosmic or divine event could have produced such an effect. For those who approach the shroud from a standpoint of faith, this theory offers a powerful and compelling convergence. It suggests that the resurrection was not a quiet, purely spiritual event, but a moment of immense physical power that left a permanent, physical record, a relic not of death but of transfiguration. For the skeptical scientist, it remains an untestable, supernatural proposition. Yet, in the stubborn, silent testimony of the linen itself, the radiation burst theory stands as the only proposed mechanism that attempts to account for the entire, bewildering constellation of the shroud's unique properties, weaving the threads of forensic science and ancient belief into a single, breathtaking tapestry of possibility. And yet, despite the mounting scientific puzzles and the compelling forensic details, we must return to the historical record and the powerful, straightforward argument that has shadowed the shroud since its very first appearance, that it is in fact an astonishingly clever and devout deception. The world of 14th century Europe provides a perfect petri dish for such a relic to be cultured. This was an age of immense faith, but also one of burgeoning relic markets. Pilgrimage was a massive economic and spiritual enterprise, and a town that possessed a major relic could be transformed overnight from a backwater into a thriving destination, flush with donations from the devout. The sudden emergence of the shroud in the small town of Liéry, France, around the 1350s, fits this pattern precisely. A local nobleman, the knight Geoffroy de Charny, presented the cloth, and the ensuing pilgrimages brought immense prestige and undoubtedly significant revenue to his family and the local church. The motive of profit and power, intertwined with genuine religious fervor, cannot be easily dismissed. In this context, the creation of a relic as powerful as the burial cloth of Christ would have been the ultimate spiritual and financial investment. This is not merely modern skepticism, it was the immediate conclusion of a powerful contemporary authority. Bishop Pierre d'Arcis, in his fiery memorandum to the anti-pope, did not mince words. He stated unequivocally that his predecessor had investigated and found the artist who had confessed to its creation. D'Arcis described it as cunningly painted, a deliberate fraud. While the political complexities of the papal schism may have influenced this condemnation, the core accusation remains a stark and credible challenge. Why would a bishop level such a specific and damning charge without compelling evidence? Proponents of the forgery theory argue that this document is the historical smoking gun, a first-hand account from the very era of the Shroud's debut, alleging a direct confession from the creator. The fact that Pope Clement VII allowed its continued veneration not as authentic, but as a representation, is seen by many not as a theological compromise, but as a tacit admission that the cloth was a man-made object for devotion, not a divine original. But if it is a forgery, how was it accomplished? This is where modern artisans have stepped in, attempting to prove that a medieval genius could have achieved the impossible with the tools of the time. One of the most notable attempts comes from the Italian chemist and skeptic Luigi Galli. His method was elegantly simple and required no anachronistic technology. He started with a volunteer who was covered in a linen cloth. He then used a stiff cloth-covered roller to apply a very dilute, acidic solution of ferric oxide and gelatin to the fabric, pressing only on the high points of the body: the nose, the brow, the cheekbones, the knuckles. This dry rubbing technique created a superficial, negative-looking image that captured the basic contours of the form. For the blood stains, he used actual blood. After the body image was set, he then artificially aged the entire cloth by baking it in an oven and washing it to give it the appearance of great antiquity. Galli's resulting shroud replica was visually striking, possessing a haunting, negative quality and a superficial stain that, to a casual observer, bore a remarkable resemblance to the original. His work is a powerful demonstration that certain aspects of the shroud's appearance can be replicated with medieval materials. The dry rubbing method avoids the use of liquid brushes that would leave telltale strokes, and the pressure-based application naturally creates a darker image on the raised body parts, simulating a crude form of three-dimensionality. For many skeptics, Galli's experiment is a compelling proof of concept. It shows that a determined and brilliant artist, using a bas-relief statue or a living model, a simple acidic pigment, and a basic understanding of contact printing, could have created the core visual phenomenon of the shroud. The known existence of acidic dyes and the long history of rubbing techniques in art, such as brass rubbing, place all the necessary components squarely within the medieval toolkit. This argument posits that we have been overthinking the mystery. The solution isn't a mysterious burst of radiation, but the application of primitive yet sophisticated chemistry and artistry. However, the scientific community, including many neutral observers, has heavily criticized Galli's replica, highlighting the vast gulf between a plausible-looking imitation and the actual shroud. Under microscopic examination, his image does not share the same unique properties. The staining penetrates the fibers rather than resting exclusively on the topmost microns. It lacks the perfect pixel-by-pixel encoding of three-dimensional distance data. The correlation is rough and impressionistic, not mathematically precise. His method cannot account for the flawless anatomical and forensic details, such as the correct placement of the wrist wounds or the presence of bilirubin in the blood. Furthermore, his process involved a living, moving model, which would have resulted in motion blur and distortions absent from the crisp, static image on the Turin cloth. Ultimately, while Galli created a fascinating artistic facsimile, it falls short of replicating the shroud's most confounding scientific anomalies. The forgery hypothesis, therefore, finds itself in a difficult position. It can provide a plausible historical motive and a general artistic method, but it struggles mightily to account for the specific high-tech data that modern science has extracted from the linen. It asks us to believe in a medieval Leonardo da Vinci of relic forgery, an anonymous genius who not only mastered art and chemistry, but also possessed an unconscious, intuitive understanding of photographic negatives and three-dimensional data projection, a knowledge that would then vanish without a trace, leaving this single, perfect masterpiece as its only legacy. The debate thus remains a profound stalemate between a historically convenient narrative and a scientifically inexplicable object. While the grand image and the bloodstains command our attention, some of the most compelling clues about the shroud's past are not visible to the naked eye at all. They exist in a miniature world, a hidden landscape of dust and microscopic fibers that have settled into the weave of the linen over centuries. To uncover these secrets, we must shrink our perspective down past the threads and into the very particles that cling to them. This microscopic evidence forms a silent, cumulative testimony, and one of its most significant discoveries involves a specific type of rock dust. Researchers performing spectroscopic analysis on particles vacuumed from the shroud's surface made a remarkable find. They identified traces of a mineral called travertine aragonite limestone. Now, limestone is common throughout the world, but this particular form, aragonite, has a very specific and telling characteristic. Its chemical signature is like a geological fingerprint. The aragonite found on the shroud was not just any variety. It was an exact match for the unique limestone found in tombs around Jerusalem, particularly in the burial caves in the vicinity of the Church of the Holy Sepulchre. This isn't a common building stone. It's the specific, porous, and fragile stone from which first-century Jewish burial tombs were carved. The presence of this exact mineral on the shroud powerfully suggests that the cloth was, at some point in its history, in direct physical contact with a Jerusalem tomb environment. It's as if a tiny, almost invisible piece of that ancient landscape hitched a ride on the linen, preserving a clue to its origin for 2 millennia. But the geological evidence doesn't stand alone. It's part of a larger tapestry of microscopic clues being painstakingly assembled. Other dust particles recovered from the cloth include grains of pollen, which we've discussed, but also spores from fungi and other organic materials that paint a picture of the environments the shroud has passed through. The ongoing analysis of this microscopic ecosystem is like a forensic environmental history. Each type of pollen or spore acts as a tiny marker, pinpointing the cloth's location to a specific region and even a specific season. A combination of Middle Eastern pollen with this specific Jerusalem area limestone creates a powerful, converging line of evidence. It's one thing to find a pollen grain that could have blown in from a great distance. It's another to find the actual dust from the floor of a tomb, a substance that would only be transferred through direct, intimate contact. This moves the evidence beyond mere coincidence and points toward a tangible, physical history rooted in the very geography of Jerusalem. The investigation extends even further into the microscopic realm with the analysis of textile fibers themselves. Researchers have identified not just the linen of the shroud, but also tiny, trapped fibers from other fabrics. Among these are traces of cotton, identified as Gossypium herbaceum, a species native to the Middle East. The presence of these cotton fibers, likely from a simpler cloth that came into contact with the shroud, is another small but significant data point. It suggests that the shroud was handled or stored alongside other textiles in a region where this specific type of cotton was cultivated and woven. When you combine this with the limestone and the pollen, a pattern begins to emerge, a constellation of microscopic evidence that consistently points east toward the ancient Levant. Each of these tiny clues, the limestone dust, the pollen, the foreign fibers, is like a single word in a fragmented historical document. On their own, they can be debated or dismissed. But when read together, they start to form a coherent sentence, a silent argument written in the language of geology and botany that tells a story of a journey beginning in a stone tomb in 1st century Judea. This is the quiet, patient work of science, building a case not from a single dramatic test, but from the accumulated weight of 1,000 tiny, undeniable facts. This intricate web of scientific and historical evidence inevitably draws us back to the original source of the shroud story, the biblical texts themselves. To place the linen cloth within its purported context, we must turn to the accounts of Jesus' burial in the 4 Gospels. and here we encounter a fascinating and complex puzzle of words and traditions. The descriptions of the burial garments are not perfectly uniform, creating a point of contention that scholars have debated for centuries. The three synoptic Gospels, Matthew, Mark, and Luke, use a specific Greek word, syndon. This term generally refers to a fine linen cloth, a shroud, and it is used in the singular. For instance, the Gospel of Mark states, "So Joseph bought a linen cloth syndona, and taking down the body, wrapped it in the linen cloth." This language paints a picture of a single, large sheet being used to envelop the body of Jesus. However, the Gospel of John, believed by many scholars to have been written later than the others, provides a more detailed and seemingly different account. John chapter 20 states, "They took the body of Jesus and wrapped it with the spices in linen cloths, orthonia, according to the burial custom of the Jews." The word used here, orthonia, is a plural noun that can be translated as linen cloths or strips of linen. This could imply multiple wrappings, similar to the bandages used in the mummification process. But John doesn't stop there. He adds a crucial, specific detail when describing the empty tomb. Peter and the beloved disciple find the linen cloths orthonia lying there, and the face cloth shroudarion, which had been on Jesus' head, not lying with the linen cloths but folded up in a place by itself. This introduces a second, distinct item, the shroudarion, the face cloth, which we now know by its Latin name, the Sudarium of Oviedo. At first glance, this appears to be a direct contradiction. Is it one cloth or multiple? The resolution of this apparent discrepancy lies in a deeper understanding of first-century Jewish burial practices. Historians and biblical scholars suggest that the process likely involved more than one textile. The body would have been prepared with spices, often placed directly on the skin or within smaller strips of cloth to hold them in place. Then, the entire body would have been enveloped in a large, single shroud, the syndon, which served as an outer wrapping. The face cloth, or shroudarion, would have been used separately, perhaps initially to secure the jaw after death or to manage the fluids from the severe head wounds, as the forensic evidence from the Sudarium of Oviedo strongly suggests. In this interpretation, the Synoptic Gospels are focusing on the primary, large shroud, while John, providing a more precise, eyewitness level of detail, mentions all the components involved, the various cloths used in the preparation and the distinct face cloth. Therefore, rather than contradicting the Shroud of Turin, the Gospel of John's account may actually provide its perfect partner, explaining the existence and purpose of the Sudarium and creating a complete, forensically coherent picture of a burial conducted with care and in accordance with contemporary customs. Yet another textual criticism arises when we consider the image on the shroud itself. The Gospels are clear that Jesus was buried in haste before the Sabbath began, and there is no mention in any of the accounts of any miraculous image being left on the burial cloths when the tomb was found empty. The focus is entirely on the absence of the body and the presence of the abandoned linens. For some, this silence is deafening. If the shroud is authentic and bears such a stunning, miraculous portrait, wouldn't such a momentous event have been noted by the Gospel writers? Wouldn't Peter and John have been utterly astonished to find not just an empty shroud, but a shroud imprinted with the perfect likeness of their teacher? The fact that they are described as simply seeing the cloths and believing suggests to critics that there was no image to see. The cloths were empty, just as the tomb was empty. Proponents of the shroud's authenticity offer a different perspective on this silence. They argue that the Gospels were written to proclaim the central, theological truth of the resurrection, not to catalogue every physical artifact left behind. The writers were conveying the core of the faith, that Jesus had risen and the tomb was empty. The presence of a mysterious image on the cloth might have been considered a secondary detail, or perhaps even a mystery that the disciples themselves did not fully understand at that chaotic moment. Furthermore, the nature of the image on the shroud is not a simple, obvious portrait. As Secondo Pier discovered, it is a latent negative image that only makes perfect sense when viewed through the technology of photography. To first-century eyes, the shroud would have appeared as a faint, discolored, and somewhat ambiguous imprint on a used burial cloth. It may not have been immediately recognizable as a detailed portrait, especially in the dim light of a rock-hewn tomb and amidst the overwhelming emotional shock of the resurrection. Its full significance as a visual document may only have become apparent upon later, more careful reflection. A reflection that perhaps occurred after the Gospels had already been committed to writing. The textual criticisms, therefore, do not provide a simple verdict. Instead, they open a window into the complexities of ancient testimony, inviting us to read between the lines and consider how a world-shattering event might have been recorded by witnesses who were struggling to comprehend the incomprehensible. If the scientific investigations of the 20th century felt like a meticulous physical examination, the dawn of the digital era has given us a set of tools that feel almost like a form of technological telepathy, allowing us to peer into the very essence of the cloth without ever touching a single thread. The most significant leap forward in recent decades came in 2002, when a team of technicians performed a monumental act of digital preservation. They created a full, high-resolution, three-dimensional scan of the entire shroud. This wasn't just a simple photograph, it was a laser scanning process that captured billions of data points, mapping the exact topography of the linen's surface with a precision down to a fraction of a millimeter. This three-dimensional dataset is now a permanent digital artifact, a virtual shroud that can be manipulated, analyzed, and shared by scientists anywhere in the world, ensuring that the original relic can remain protected in its climate-controlled case while the investigation continues unabated. The implications of this are profound. Researchers can now zoom in on a single bloodstain or image fiber, rotate it in virtual space, and measure its properties with a level of detail that was unimaginable during the 1978 examination. It allows for a kind of collaborative, global autopsy, where a pathologist in the United States can examine the wound on the wrist in minute detail at the same time as a textile expert in Italy studies the herringbone weave, all working from the same perfect, unchanging digital copy. One of the most startling discoveries to emerge from this digital deep dive involves the very wounds that mark the man's body. For centuries, scholars have debated the exact nature of the wound in the side, described in the Gospel of John as being inflicted by a Roman soldier's lance. The traditional depiction in art shows a single, neat puncture, but when scientists applied advanced image processing algorithms to the high-resolution scans, they found something much more complex and brutal. The wound appears not as a simple slit, but as a larger, elliptical laceration with a distinctive tear, suggesting the spearhead may have been twisted or pulled downward, a savage movement consistent with a soldier ensuring a fatal injury. Even more compelling, the digital enhancement revealed what appears to be an impression of the object itself, a faint, ghostly outline around the wound that some researchers have interpreted as the mark of the Roman lancier's specific shape, a detail completely invisible to the naked eye. This is the power of the digital age. It allows us to see not just what is on the cloth, but to begin deciphering how it got there, recovering lost forensic data from 2,000 years ago. Beyond three-dimensional scanning, another suite of powerful tools has been brought to bear: multispectral imaging. Where the human eye sees only a narrow band of visible light, multispectral cameras capture images at many different wavelengths, from ultraviolet to the far infrared. Each wavelength of light interacts with matter in a unique way, revealing secrets that are otherwise hidden. When applied to the shroud, this technology has acted like a form of archaeological peeling, allowing scientists to separate the different layers of information embedded in the cloth. They can create an image that isolates the bloodstains from the body image, or one that highlights the scorch marks from the 1532 fire, viewing each component in isolation to understand its individual properties. This has been crucial in the ongoing debate about the image's origin. By analyzing the spectral response of the image fibers, researchers have been able to confirm with even greater certainty that there are no pigments or dyes present. The coloration behaves spectrally like a chemically altered form of the linen itself, not like an applied substance. It has also revealed faint, previously unseen traces, such as possible impressions of coins over the eyes or faint writings along the edges, though these findings remain hotly contested. The multispectral data acts as a truth serum for the linen, forcing it to reveal its composition in the pure, unbiased language of light physics. Perhaps the most tantalizing promise of the digital age lies in the realm of new dating techniques. The controversy surrounding the 1988 radiocarbon tests has never fully faded, and many scientists believe that the question of the shroud's age deserves a second look with more advanced technology. The problem with the original test was its destructiveness. It required cutting and burning a piece of the cloth. Today, researchers are developing non-destructive or minimally destructive methods that could date the shroud without causing it any harm. One promising avenue is the use of accelerated mass spectrometry with smaller samples. While still requiring a tiny fragment, newer machines are so sensitive they could potentially work with a sample weighing 1,000 times less than what was used in 1988, perhaps just a few single threads. This would allow for multiple samples to be taken from different parts of the cloth, including the main body image area, which could finally test the invisible reweave hypothesis by comparing the date of the controversial corner to the date of the clearly original center. Other futuristic-sounding techniques are also on the horizon. Some scientists propose using analyzers that measure the cumulative damage to the linen's cellulose at a molecular level. Over centuries, linen fibers are bombarded by background radiation and undergo slow chemical degradation. By using techniques like Fourier transform infrared spectroscopy or analyzing the breakdown products of cellulose, it might be possible to develop a new kind of chemical clock that could estimate the cloth's age based on its molecular state. Another proposal involves using laser spectroscopy to analyze the patina of dust and minerals on the shroud's surface, comparing its composition and depth to known archaeological artifacts from the 1st century. The fundamental goal of all these efforts is to move beyond a single, contested data point and build a multifaceted age profile for the cloth, using a battery of independent tests that, if they converge on the same conclusion, would be virtually impossible to refute. We are no longer limited to asking the shroud one question with one imperfect tool. We are now learning how to have a full, nuanced conversation with it, listening to its story through the combined voices of physics, chemistry, and digital science. The mystery that has endured for 7 centuries is now being pursued by the tools of the next millennium, and the final chapter may yet be written in lines of code and streams of data. But beyond the sterile environment of the laboratory and the hallowed halls of the cathedral, the Shroud of Turin has taken on a life of its own, seeping into the very bloodstream of our global culture. It has become more than a relic. It is an icon, a symbol of ultimate mystery that transcends its origins to captivate artists, writers, and filmmakers. Its presence in popular culture is a testament to its unique power. In Dan Brown's blockbuster novel, The Da Vinci Code, the shroud is presented as a key piece of a vast historical conspiracy, a clever medieval forgery used to cement the power of the church. This fictional portrayal captures one popular perception perfectly: the shroud as an elaborate and successful hoax, yet in other stories it serves a completely different purpose. In the television series The X-Files, the shroud is investigated by agents Mulder and Scully as a paranormal object, an artifact whose properties defy conventional explanation, aligning with the "I want to believe" ethos of the show. It has appeared in films from historical dramas to science fiction, each project using the cloth as a blank canvas to project its own narrative, be it one of faith, skepticism, or extraterrestrial intervention. This cultural appropriation reveals a fundamental truth. The shroud is a Rorschach test for the modern world. What you see in its faint, ghostly image often says more about your own beliefs concerning science, history, and the divine than it does about the cloth itself. For some, it is undeniable proof. For others, it is the ultimate cold case, an unsolvable puzzle that challenges our assumptions about the past. This symbolic power transforms the city of Turin and the shroud itself into a living, breathing cultural phenomenon. On the rare occasions when the cloth is removed from its hermetically sealed case for a public exhibition, the city is transformed. Millions of pilgrims and tourists from every corner of the globe descend upon the Italian city, creating an event of staggering scale and profound emotion. The lines stretch for miles, a river of humanity flowing slowly through the streets, a silent, multi-day procession of the faithful, the curious, and the skeptical. For many, this is not a simple tourist outing. It is a pilgrimage, a spiritual journey of a lifetime. They wait for hours, not with impatience, but with a palpable sense of anticipation. When they finally enter the dimly lit cathedral and stand before the cloth, the reactions are deeply personal and powerfully moving. Some weep openly, others pray fervently, and many simply stand in silent, awestruck contemplation. In that moment, the scientific debates and historical controversies fade into the background. What remains is the raw, human encounter with an object that represents for them the very core of suffering, sacrifice, and hope. The shroud in these displays ceases to be a subject of academic debate and becomes a mirror for the soul, a focal point for the deepest questions of existence that have haunted humanity since the dawn of time. The economic and social impact of this phenomenon is immense, but it is the intangible effect that is most remarkable. The shroud has spawned its own unique ecosystem of devotion and inquiry. There are international research organizations, dedicated websites, countless books, and annual conferences where scientists, theologians, and historians gather, often with vastly different worldviews, united by their fascination with this single piece of linen. It has inspired artists to create their own interpretations, from faithful replicas to abstract works that explore the themes of imprint and memory. It serves as a common reference point in conversations between believers and non-believers, a bridge that allows for dialogue about the biggest questions precisely because its own nature remains stubbornly unresolved. The shroud's true legacy, therefore, may not be a definitive answer to its own origin, but its unparalleled ability to generate wonder. It forces us to confront the limits of our knowledge, to sit in the uncomfortable but fertile space between faith and reason. It is a permanent invitation to inquiry, a silent challenge that has endured for centuries, reminding us that some mysteries are so profound that they refuse to be solved, choosing instead to inspire, to provoke, and to unite us in our shared, enduring quest for meaning. And so, after centuries of scrutiny, from the eyes of faithful pilgrims to the electron microscopes of elite scientists, the Shroud of Turin remains suspended in a state of profound ambiguity. It is an object that refuses to be categorized, a riddle that consistently generates new questions for every potential answer it offers. The debate is kept fiercely alive not by a lack of investigation, but by an abundance of perplexing, unresolved mysteries that challenge the very foundations of our understanding. Perhaps the most persistent of these enigmas is the one that greets every modern researcher who tries to solve it. Why, with all our 21st century technology and knowledge, can we not replicate the image? We have successfully mapped the human genome, sent probes beyond our solar system, and peered into the quantum realm, yet this single piece of linen from a supposedly primitive era defies duplication. Laboratories around the world have attempted every conceivable technique, from sophisticated laser etching and radiation bursts to medieval-style contact scorching and chemical vapors. Each attempt produces a fascinating simulacrum, but every one falls short in some critical way. the replicas lack the perfect pixel-level encoding of three-dimensional data. Their stains penetrate the fibers too deeply or appear in unrealistic, blotchy patterns. They might capture the look of the shroud, but they fail to capture its inexplicable being. This ongoing failure is a continuous, silent testament to the shroud's unique nature. It suggests that the process that created it, whether divine or diabolical, natural or supernatural, involves a principle or a technology that remains just beyond the grasp of contemporary science. This leads directly to the second, and perhaps most scientifically baffling, question. How does one explain the perfect three-dimensional information encoded within the image? This is not an artist's clever use of light and shadow to create an illusion of depth. This is a precise mathematical relationship. The darkness of every single point on the image corresponds exactly to the distance that point of the cloth would have been from the body it covered. It functions less like a painting and more like a topographical map of a human form, or a scan from a medical imaging device. For a forger to have achieved this in the 14th century, they would have needed to possess an intuitive, subconscious understanding of a concept that wouldn't be formally developed for another 600 years. They would have had to mentally calculate how the intensity of their chosen medium should vary across a complex, three-dimensional surface, and then execute that vision with a technique that somehow applied more colorant to the high points and less to the low points without using a brush, without any liquid pooling, and without leaving a single directional stroke. The sheer, staggering improbability of this is often the central pillar of the authenticity argument. It forces us to consider that the image was not made in the conventional sense at all, but was recorded or projected by a physical event that naturally encoded that spatial information, an event like a brief, directional burst of energy emanating from the body itself. Conversely, if we are to accept the radiocarbon dating and declare the shroud a medieval forgery, we are immediately confronted with an equally difficult set of questions. What precisely was the method, and why has this method remained a secret, utterly lost to history? The forger in this scenario would have been a figure of unparalleled genius, a fusion of Leonardo da Vinci, a master chemist, and a forensic pathologist with lost knowledge of Roman crucifixion. They would have needed access to real human blood, which they applied with anatomical precision that matches modern medical understanding. They would have had to invent a painting technique that used no paint, a staining process that left no liquid residue, and a way to create a perfect photographic negative centuries before the camera was invented. And after accomplishing this singular, miraculous feat of artistic and scientific deception, this anonymous master would have taken their secret to the grave. No plans, no trial pieces, no written records, no boasts to contemporaries. The shroud would stand as the one and only artifact of its kind, a perfect storm of genius emerging from the Middle Ages and then vanishing without a trace. This narrative asks for a suspension of disbelief that, for many, is as great as believing in a miracle itself. Even if we grant the possibility of such a brilliant forgery, the historical journey of the cloth presents its own labyrinth of unanswered questions. If the shroud is authentic, how did it travel from a tomb in 1st century Jerusalem to the possession of a French knight in the 1350s without leaving a clear, continuous paper trail? Proponents of its authenticity have constructed elaborate and fascinating theories to fill this gap. They point to a possible early history connected to the ancient city of Edessa, home to a famous image of Edessa cloth, which some believe was the shroud folded to show only the face. From there, the theory goes, it was taken to Constantinople, the capital of the Byzantine Empire, where it was revered as a major relic. Historical records from the year 944 describe a Sindon in Constantinople, and it is documented that when the city was sacked by Crusaders in 1204, many relics were looted and transported to Europe. Could the shroud have been among them, perhaps falling into the hands of the mysterious and powerful Knights Templar, who then secretly safeguarded it until it eventually surfaced in the possession of the Templar-descended family of Geoffroy de Charny? It is a compelling narrative, a historical detective story woven from fragments of texts, art, and tradition. Yet, for every piece of circumstantial evidence that seems to fit, there is a missing link, a document that doesn't exist, a definitive reference that would cement the chain of custody. The path from Jerusalem to Lyre remains shrouded in the fog of history, a ghostly journey that is plausible but not yet proven. Ultimately, the enduring power of the Shroud of Turin lies in this very state of uncertainty. It is a catalyst for wonder. For every argument from science, a counter-argument from history arises. For every piece of data that seems to point toward authenticity, another piece appears to refute it. The carbon dating says medieval, but the pollen and limestone whisper of the ancient Middle East. The image is scientifically inexplicable, yet it appeared in an era known for its relic forgeries. It is this perfect, maddening equilibrium of evidence that ensures the debate will never truly die. The shroud does not offer proof, it offers a mystery. It invites us to explore the boundaries between faith and reason, between artifact and icon, and between what we can explain and what we can only wonder at. It stands as a permanent question mark in human history, challenging us to consider that some secrets are so profound they are meant not to be solved, but to be pondered for generations. Looking ahead, the investigation into the Shroud of Turin stands at a technological crossroads, poised between the methods of the 20th century and the revolutionary tools of the 21st. The central, most pressing question remains its age, and the controversy surrounding the 1988 radiocarbon dating ensures that any future test will be subject to immense scrutiny. The most likely path forward involves the development and application of new, non-destructive or minimally destructive dating techniques. Scientists are actively exploring methods like laser-induced breakdown spectroscopy, which could potentially analyze the molecular degradation of the linen's cellulose by vaporizing a microscopic, virtually invisible amount of material. Other approaches might involve advanced chemical analysis of the patina of dust and minerals embedded in the cloth, comparing its composition to that of artifacts with a firmly established first-century provenance from the Jerusalem area. The goal is to move beyond a single contentious data point and build a multi-pronged age profile using a battery of independent tests. If techniques like these were to converge on a date from the 1st century, the impact would be seismic, forcing a complete re-evaluation of the cloth's journey and its place in history. A more definitive resolution, however, hinges on the willingness of the Vatican, the Shroud's custodian, to authorize a new, carefully orchestrated sampling for improved carbon dating. The memory of the 1988 test and its ensuing controversy has made the Church justifiably cautious. Any future protocol would need to be exponentially more rigorous, involving a larger, international consortium of experts from diverse fields including textile conservation, chemistry, and archaeology. The sampling strategy would be critical. Instead of a single piece from one corner, multiple microsamples would be taken from several different locations across the cloth, including the main body image area far from any potential medieval repairs or fire-damaged sections. These samples would then be distributed to a wider array of laboratories, all operating under a strict, transparent, double-blind protocol with even more sophisticated contamination controls. The political and theological stakes of such a decision are immense. A confirmed medieval date would likely diminish the shroud's status as a central relic for many of the faithful, while a confirmed 1st century origin would not prove it was Jesus, but would catapult it to a position of unparalleled historical and spiritual significance. The Vatican's deliberation is therefore not just scientific, but a profound weighing of pastoral responsibility against the human yearning for tangible certainty. Beyond dating, the next frontier of shroud science almost certainly involves genetics. The dust and microscopic debris vacuumed from its surface represent a frozen snapshot of its entire history, a biological archive containing pollen, fungal spores, and perhaps even fragments of human DNA from all those who have handled or been near it over the centuries. The application of modern DNA sequencing to this material could be revolutionary. By extracting and analyzing the ancient DNA trapped within the weave, scientists could, in theory, map the geographical and ethnic origins of the people associated with the cloth. They could identify genetic markers pointing to Middle Eastern ancestry, potentially even building a rough genetic profile of the man whose blood stains the linen. However, this path is fraught with both technical and ethical challenges. The DNA would be severely degraded and mixed with contamination from countless other sources across 2 millennia. Isolating a single primary genetic signal from this cacophony would be a monumental task. Furthermore, even if a clear DNA profile were obtained, it could never, ever provide a certified name. There is no first-century DNA database for comparison. The result would be another compelling piece of circumstantial evidence, not a definitive identification, and it would open a complex debate about the ethics of genetically profiling a figure central to a world religion. This brings us to the philosophical heart of the matter. Will the mystery of the Shroud of Turin ever be definitively solved? It is entirely possible that future tests will yield yet another set of contradictory or ambiguous results, perpetuating the stalemate. The carbon dating might be successfully challenged, only for DNA analysis to prove inconclusive. A new physical model for the image formation might be proposed, yet still falls short of perfect replication. The shroud seems to possess a kind of perpetual elusiveness, a resistance to final categorization, and perhaps in that very resistance lies its true and enduring power. Its unyielding mystery is what makes it a unique bridge between the empirical world of science and the intangible realm of spirit. For the skeptic, it is a fascinating historical and scientific puzzle that highlights the limits of our knowledge. For the believer, it is an object that invites faith, not as a blind leap, but as a reasoned response to a phenomenon that transcends complete material explanation. The shroud does not offer proof, it invites wonder. It forces a conversation between disciplines that rarely speak the same language, creating a space where a physicist and a theologian can stand side by side, equally humbled and captivated. Its future may not lie in a single, bold headline declaring the case closed, but in its continued role as a catalyst for inquiry, a silent, enduring monument to the human quest for meaning in the face of the unknown. From the dusty archives of 14th century France to the sterile glow of 21st century laboratories, the journey of the Shroud of Turin is unlike any other in human history. We have walked alongside kings and knights, scientists and skeptics, believers and forgers, each trying to claim this piece of linen for their own narrative. We have seen how a single photograph transformed a faint, ghostly imprint into a stunningly detailed portrait, revealing a negative image that no medieval mind could have conceived. We have delved into the brutal forensic evidence, the wounds that speak with chilling accuracy of a Roman crucifixion, written not in ink but in real human blood. We have witnessed the bafflement of elite scientists armed with the best technology of their age, who could only conclude that the image was not a painting, yet could not explain what it was. We have grappled with the shock of a radiocarbon date that seemed to settle the debate, only to watch as compelling evidence of contamination and repair cast that very verdict into profound doubt. This cloth has survived fire and scrutiny, faith and ridicule, emerging from every challenge not with an answer but with a deeper, more resonant question. It is an artifact that simply refuses to be pigeonholed. It is potentially a sacred relic of the highest order, a tangible connection to the divine that has inspired millions. It is, just as plausibly, the most brilliant and enduring hoax ever created, a testament to human ingenuity and the power of belief. But no matter which side of that divide you find yourself on, one thing is undeniable: the Shroud of Turin is a definitive masterpiece of mystery. Its power does not come from providing certainty, but from its relentless defiance of it. It sits perfectly balanced at the intersection of faith and reason, challenging the very foundations of both. For the believer, it offers a physical object that aligns with their deepest spiritual convictions, a silent witness that seems to confirm 2,000 years of tradition. For the skeptic, it presents a historical and scientific puzzle of the highest order, an anomaly that pushes the boundaries of what we know about art, history, and human capability. And for everyone in between, it serves as a profound invitation to wonder, to sit with the unknown and contemplate the possibility that some truths are too complex for a simple label. So now we bring this exploration to you, after traversing this incredible landscape of evidence and counter-evidence, of science that points to divinity and history that suggests deception. The most important question remains. It is not a question for the laboratories or the history books anymore. It is a question for you. After all you have seen and heard, where do you stand? When you look upon the face from the shroud, does your reason provide the final answer, pointing to the carbon date and the lack of a continuous historical record? Or does your faith provide the answer, drawn to the inexplicable image, the forensic precision of the wounds, and the silent, powerful testimony of the cloth itself? This is the enduring legacy of the Shroud of Turin. It is a mirror for the soul, reflecting back our own deepest assumptions about the world, about history, and about the very nature of reality. We would love to hear your thoughts in the comments below. What piece of evidence was most compelling to you? Where does the balance of proof lie from your perspective? If you enjoyed this deep dive into one of history's greatest enigmas, be sure to like this video and subscribe to the channel for more journeys to the heart of the world's most captivating